Minimum sum theory, part 3. In the last two presentations, part 1 and part 2, we introduced for normal data or normal arithmetic progression and normal discrete data. This presentation here is talking about introducing the same idea or the same theory here, minimum sum theory, for continuous data within an interval. Continuous interval 0, 1. So it means if you have got an interval, the data is continuously distributed between 0 and 1. Definitely there are infinite numbers between 0 and 1, 0.01, 0.05, 0.99, and so on. So now the aim of this presentation here is to introduce the minimum sum and find a general formula to identify the minimum sum for this interval if the data is continuous. Let us now split the interval into n subintervals or segments. Therefore, the width of each segment simply is 1 divided by n. This 1 divided by n originally comes from 1 minus 0 divided by n, but definitely here 0 we will not write it down, and then this is 1 over n. Now let us rewrite this interval as a descending positive arithmetic series. So the interval 1 to 0 this time, because if you can remember from our previous presentation when we started developing this theory, we did talk about that one requirement before you apply the algorithm is the data has to be in descending order from the largest to the smallest. So we do the same thing here. So the interval originally is 0, 1, but we represent it as 1 to 0. And then if x is that arithmetic progression here, the first number definitely is 1, and because the segment width is 1 over n, definitely the next one going down towards 0 is 1 minus 1 over n. The next one to that, the third term, is 1 minus 2 divided by n, and so on. The term just before the last is 1 minus n minus 1 divided by 1, and then finally here this is 0. Reference to the previous presentation of the minimum sum theory in part 2, then if you can remember, we developed this formula. The S minimum is equal to 0 if n, the size of the data or arithmetic series or the number of arithmetic series is 4m. m is 0, 1, 2, 3, and so on. And the S minimum is equal to D, the common difference, if, for example, n, the size of the data is 2 plus 4m. Again, m is 0, 1, 2, 3, and so on. The rest of possibilities for n is if n is odd, but we split the odd numbers here into two categories, 3 plus 4m, in which S minimum is equal to A minus 3 plus 4m times D, or if the second possibility of n as odd is 5 plus 4m, and then S minimum is equal to A minus 4 times 1 plus m, then close the bracket, times D. So we now introduce the same thing here. Conclusion. So now if we apply this situation here, if n is, although n in this case here, do not forget, is approaching infinite, but still if n is multiple of 4, automatically here this is going to be the first solution in which the S minimum is equal to 0. The second case here, which is still even number, is equal to 2 plus 4m, and m is 0, 1, 2, 3, and so on, then S min is equal to 1 over n. If you can remember, this was D, the common difference in the arithmetic series. But if n approaches infinite, then again here the S min will approach and become 0. The third possibility here is if n is odd. But when n is odd, we split into two categories. One of them is 3 plus 4m. If you substitute it back to here, and then after multiplication, because a is 1 in this case, and then you will again get equal to 0. The last possibility for the odd number is 5 plus 4m, and then if you do a simple mathematical calculation, again S min will become 0. So it means the final conclusion is fairly now easy. For continuous interval between 0 and 1, the S min is equal to 0. And this is a new interesting result. Finally here, I leave a question for the reader. For any interval alpha to beta, alpha can be any positive number and beta can be any positive number, work out or develop a theory or a formula stating S min. Thank you.